Welcome back to the night class. We're going to start chapter 6 today. Chapter 6 deals with radians. It's basically a repeat of chapter 5, just instead of using degrees, we're using radians. So, what is a radian? A radian is equal 1 pi radian equals 180 degrees. Basically, they take the radius of the circle. Boom. Oh, that's an ugly color. Okay. The radius from there to there, and they extend it on the circle, and that would be 1 radian, basically, is what's happening here. Okay? So you do that two more times, you get to 3 and a little bit more, which is pi. Okay? 180 degrees is pi radians, which means 360 degrees is 2 pi radians. Okay? Very, very simple. If you ever need to know like the decimal part, 1 radian is 57.3 degrees. Might be a good Jeopardy question. 1 degree is 0.017 radians. But you very rarely have to do it like that. Most of the time you're just simplifying. So examples, these are on page 348 of your textbook if you want to look. We are just changing degrees to radians and radians to degrees. So it's very, very simple. If you're going from degrees to radians, you multiply by pi over 180.
Does ours need to be calculated to be in radian now?
That only matters. Okay, that's a very good question. Your calculator mode only matters if you're plugging in sine, cosine, tangent of things. Okay? If you're doing the sine of pi, your calculator needs to be in what?
Degree?
Nope.
Radians.
Radians. Okay, pi is radians. If you're doing sine of 187 degrees, it needs to be in degrees. Okay? You will always know it's degrees when there's a little circle there. That's why it's so important that you put it there. Okay? If there's no circle, guess what it's in? Radians. Okay? They may put RAD for radians, but I doubt it. Okay? So just know this is all you're doing. And basically, in your calculator, you're just going to type 240 over 180 and hit math, enter, enter, and reduce that fraction. Okay? They don't want the decimal. Okay? They want it in fraction form. So what is 240 over 180 reduced to? 4 over 3. So that is 4 pi over 3 radians. Done. Okay? Number 6, the same way. Pi over 180. And again, you're saying 570 divided by 180. Hit math, enter, enter. And what does that give you? 19 pi over 6. Any questions on how to convert degrees to radians? Okay? 7 and 8, we're going the other direction. We're going radians to degrees. So, what do you think we multiply by? 180 over pi. You just flip it. Okay? That's all you're doing. You're just flipping it. You'll always know which one is on top by what you're looking for. If you're trying to find radians, you're going to put the pi on top. If you're trying to find degrees, you're going to put the 180 degrees on top. Okay? These degrees, like on the ones we just did, they cancel. They're no longer a degree, and we're left with radians. Okay? Y'all have science class where you have to do your conversion tables or whatever and cancel everything out. It's the same process. Okay? So 3 pi over 2, and we're going to change that to degrees. So I'll multiply by 180 over pi. The pi's do what? Cancel. And basically you just have to say 3 times 180 divided by 2, and you should get, I believe, 270 degrees. Is that correct? 3 times 180 divided by 2. Or 3 over 2 times 180. However you want to put it in your calculator. Or in your brain. Number 8. Again, 180 degrees over pi. you're not going to have a nice pretty number here, but notice the directions on these tell us to round to the nearest what? 10th. So you just stick that in your calculator and you round to the nearest 10th. What would that be? You put negative 1.75, parentheses, 180 divided by pi. And use the pi button. Don't use 3.14. Does everybody know where the pi button is on your calculator? Yes, second little house top, right above the division sign on your calculator.
That's the YouTube stream on the side. They
The
have like a little
YouTube.
house top over like the YouTube button.
You're right.
You can comment that on people's videos now. I think for a reason.
Everybody good on how to put it in your calculator and round? Paris, you good? Caden, you good? Okay.
I just had to do it in my check.
Yes, always better to do it. All right. All right. You good? Yes, ma'am. Correct. The pi's canceled. You can put if you're putting it in your calculator and you put the pi's in, it's going to be okay. The calculator will cancel them too. I'm just saving a step, okay? And also, it's kind of hard the way it's written. You can see it a little better when when you write it like normal. You can see that the pi's do cancel, but when it's written sideways like that, it's kind of hard to see. Okay, everybody good? All right, 9 and 10. We are basically, it says use your chart. I am going to give you a chart for future reference. You can use it, but only it's kind of like a cheat sheet. Here, what I would do is I'm going to change that to degrees and do it like we did last chapter. Okay? So what is 3 pi over 2? We just found it. What is that in degrees?
270.
That's 270. Okay? And we don't ever lose this. So sine 270, where is it? Which quadrant is 270 in? It's on the line. It's not in a quadrant. It's one of these. Y'all remember these? So we got to figure out what is that point. 0, -1. And then we got to do our U rock, excellent rock, U excellent. Okay. I'm going to say this is the unit circle, right? So sine is just equal to y. What is my y?
1.
Nope. -1.
Oh. Radius.
Okay.
Is 1, right?
It is y over r, but since it's the unit circle, I know r is 1. -1 over 1 is -1. Okay? Any questions? Same thing, like I said, it's just like last chapter, only it's giving it to you in radians. All right? What about 11 pi over 6? What would that be? If I multiplied it by 180 over pi, what would that give me? Tangent of what? Is it 330?
Yes. Yes.
Anybody else get 330? Majority got 330, all right? So, 330, what quadrant would that be in? Fourth quadrant. So, I'll come over here, draw my angle in the fourth quadrant. What would my reference angle be for 330 degrees? How much?
30.
30. Okay. So this is what kind of triangle? It is a 30, 60, 90 triangle, which means my short leg I'm going to let be 1. My hypotenuse is then what? The short leg times what? 2. Short leg times 2. And then the long leg is the short leg times the square root of 3. Every single time.
So what do you do if
Okay.
you don't know 30 and 60 triangles? Can you use like?
You need to know 30, 60, 90
I
triangles.
don't.
Learn them.
Okay.
Okay? All you got to remember, everything goes off the what leg? Short leg. Then you just got to remember the hypotenuse is twice as long as the short leg. Always. And the long leg is the square root of 3 times the short leg. That's why I made the short leg what? 1. Remember, you can make it any way you think you want to. I could have made it 10. That would have made that what though?
That'd be
20 and then 10 square root of 3. Okay? So you make it anything you want to. Make them stuff that's easy. Okay? There you go. Boom. All right. So tangent, I can do SOHCAHTOA on this one. Would be opposite over adjacent. What is opposite? 1. Oh, I forgot something. What kind of 1 is that? -1. Okay, because I went down. -1 over the adjacent is square root of 3, which will be negative square root of 3 over 3 simplified. Okay? You can find pretty much any angle like that, and just be prepared. Most of your angles will end up being 0, 30, 45, 60, or 90. Okay? Most of them. So, know them good.
Hold up.
All right?
Trying to listen.
I think that's enough math for today. My brain's kind of tapped out.
You can also, I lied to you. You said, what do you do if you don't know the triangle? You can do something. You can use your hand trick. So, briefly, here's my fingers, right? 0, 30, 45, 60, 90. All right, so if I'm doing 30 degrees and I'm doing tangent, okay? Tangent is the square root of the number of fingers to the right over the square root of the number of fingers to the left. So how many fingers are to the right of the one I have down? 1. So square root of 1 would be 1 over the square root of what? 3. Square root of 3.
But it's not negative.
Then I use my all-star trig class, and I realize, is tangent positive in that fourth quadrant? No, so I know I have to make it negative. Okay? So, again, that's just, that's the easy way. Okay? Remember, you do...
But if you know that your angle is 30, couldn't you say like, oh, well, you only know that angle, so you couldn't use like tangent or sine or whatever to find a side.
Do what now?
I was thinking in my head, like, could you use like
Sine of
thinking like tangent of 30 is opposite over adjacent.
Right.
But you don't know one of yours what one.
Correct.
So
You would have to make up
right, it'd be
one.
tangent 30 over.
Yes.
Yeah. That's
Yes.
what I was saying.
Okay. All right.
It just took me a while to articulate.
Last few. We're doing area and length of an arc. I briefly explained this before we started videoing. The length of an arc, the formula is that, okay? S equals R theta. Theta has to be in radians. I'll say that again. To use either one of these formulas, theta has to be in radians, okay? R is the what? Radius. Theta has to be in radians, okay? So when it says the length of the arc, you're talking about how long is that arc right there? Okay? That making sense? All right? Again, if we're talking about the entire circle, well, what's my theta? If we're talking about the entire circle, how many radians is one full round? 2 pi. So if I plug in r times 2 pi, I get 2 pi r, which is my circumference formula. Okay? It's the same thing. Most of the time, though, we're not finding the entire circle. Okay? Here is your area of a sector. Now, the area of a sector is just a piece of the circle. Can you get the area of the whole thing? Yes. What would the theta be if you're finding the area of the whole thing? 2 pi, because we're going all the way around. So again, it simplifies 1/2 r squared times 2 pi. The 2's cancel, and you're left with pi r squared, which is the formula for the area of a circle. Okay? Like I said earlier, you've been using radians your entire life without knowing it. Okay? Ever since you learned the area formula and the circumference formula of a circle, you've been using radians. Okay? So, it's very, very simple to put into practice. Like I said, they're wanting you to find just a part of a circle. So for 11 and 12, we're finding the, where does it say, the length of its intercepted arc. So we're finding the arc length. It's very, very simple. You just plug in. I'm going to write it S equals R theta. I write it every time I have a problem. So when I finally get on the test, I will have it memorized. Okay? What is my radius? It gave those in the directions. It has a radius of what? 15. And theta is 5 pi over what? 6. So you just plug in. S equals 15 times 5 pi over 6. And you round to the nearest 10. So what is 15 times 5 pi over 6? 79.3? 39.3. Thank you. And 39.3 what? What are we measuring in here? Inches. Okay? The angle is in radians, but we're finding the length. Okay? Everybody good on that one? What's wrong with 12? It's in degrees. So you can do one of two things. You can change it to radians to begin with, or you can just include the conversion in your equation. So what do you mean by that? Well, I'm going to say S equals R theta again. So we're still going to have 15. 77, what do I multiply it by to get radians? Pi over 180. So I just put it, rather than putting 77, I'm going to put 77 pi over 180. I just include it in my solution, okay? Or in the work. 180 degrees, yes. I'm saying 77 times pi over 180. And then you just stick that in your calculator. Racing all of you. 20.2. And again, that would also be inches. Okay? Any questions on that? Pretty simple.
I need just a second to like.
All right. We are on hold. Online people, Kaylee is processing.
It amazes me how smart you are. How do you remember all this stuff?
Once you do it for however many years I've been doing it, it's pretty simple, actually. You'll remember it. You'll remember it.
No.
Yes, you will. You may not 20 years from now, but for a week or two, you're going to remember it, okay? You already do the area one? Same thing. Again, it's just plugging in. Oh, it won't let me go down any further. Okay, so down here, area, 1/2 r squared theta. So that's 1/2. What is my r for this problem? 1.4 squared times 2/3 over pi. And again, you just put it all in your calculator and round to the nearest tenth. Okay? Very, very simple if you know the formula. 0.5 times 1.4 squared times 2 pi divided by 3. Did I get a small number? I did as well. 2.1. Is that what I got?
Yeah.
2.1. And it doesn't tell us what we're measuring in, so that would just be units, some kind of units squared, because we are finding what? Area. Area is always units squared. 2.1. It won't let me. Maybe it will now. Hey, that worked. Is that a little better? All right. What's 14's problem? Why is it a little harder? It's in degrees again. Okay, that's the thing you got to look out for. Don't just be plugging in degrees. They have to be in radians. Okay, the formula doesn't change. It's still 1/2 r squared theta. All right, but you got to change that theta to radians. Okay, so 1/2 r is 6 squared. How am I going to change 54 degrees to radians? I just say what? 54 pi over 180. That's all you got to remember. 54 pi over 180. Put all that in your calculator. It's quite a bit. They're saying they get 17. I don't know if that's right.
Well, it's 16.96.
You got 17? God bless you. I got 16.96, which would be 17. Bam.
We're just like plugging stuff in.
Yep. That's it. As long as you don't forget the formula, very, very simple. Okay?
What if we forget the formula?
Then very, very hard. Y'all have a great day. See you next time. Stay above the line.